So assalamu alaikum everyone. So in today's session we'll be dwelling in the details of machine learning. So now you have some basics and you know how to code, and then you have learned some libraries as well. You know how to interact with databases. Now the only thing that we have left as an initial part is how to analyze the data, and for that we are doing the exploratory data analysis, EDA. It's exploratory data analysis. Before going into depth, what do I mean by exploratory data analysis? I would like to give you a brief what's called as machine learning pipeline. So by machine learning pipeline, I mean the steps that are involved in machine learning. Steps involved in machine learning. Like I'll give a general overview of the steps. They won't be the exhaustive steps. We'll have more or less steps in algorithms and things like that. But more or less the algorithms or the models that will train, they'll follow this sort of template. So the first thing that we have in here, that's called as data collection, because I told you everything here basically works on data. So this is the first step. So here we will have data collection, because we'll make machines learn on the data, whatever data we have. So our machines will learn on that. So for that purpose, the first step is we must collect the data. So data collection can be regarding a problem. For example, if you are solving a problem that's related to, let's say, medical, and you know the health records of many people. So for that you have to collect the data. Then the second step that we have, that's called as data pre-processing. So then we have data pre-processing. So when you are done with the data, now you have to process the data. So there are a lot of things that can be there in data. For example, there will be missing values, there will be some outliers in the data, and you have to normalize the data and things like that. For that you have to perform pre-processing. This is step one, and then we have the step two of data pre-processing. So after that, the third step we have in the pipeline, it's called as feature engineering. So what is this feature engineering? So when you collect the data, now you have different features in the data, because you have collected a lot of features. Some features can be irrelevant, some will have more priority over the other. So you have to select features carefully, because you don't want your machine learning model to be so complex that you cannot deploy the things. So there's a general formula that if a model is really easy and it works, you should use that rather than using a complex model. So best thing is you can use feature selection and feature extraction methods in here. So there are different methods. Each of this in pipeline is basically itself in a huge process. So there are multiple steps involved in each of these steps. So as you saw that we have collected the data, then we pre-process it. Then there are different features. Now you want to select the features, and then you want even sometimes extract the features. There are some techniques called as damage reduction techniques, such as PCA, principal component analysis, TSNE, and other techniques like which are used for feature extraction. Then we have feature selection method, which features to select. We'll learn about all of these steps. So this is the third step that is usually involved. That's called as feature engineering. So we have to select the features. Then we'll separate the data into training and test parts. Then comes our meat of the machine learning. We have to apply some model on the machine learning. Here we call it as selecting a model. Selecting a model. It can be an algorithm like uh, KNN and k-nearest neighbors, or we can have SVMs, or we can use neural networks or things like that. When we select this model, so in the same step we can train the model. So selecting a model and then training it. I'll write selecting a model and maybe training also. So now you selected a model, then you have to train that model as well. So when you train the model, then comes the testing and validation phases. So we'll test and validate. So we have testing and validation. We have to learn about all of these processes. So I told you that when do you do feature engineering. So here there is a step, you will split the data split the data into train and test. So when you have this data, now you have the path of the data. You'll use some portion of the data into training set and some portion into the testing set. So on the training set, you will train this model. So training set will go here. Whatever the data you had, so you'll split that. And then we'll have something called as validation. Maybe you will have a separate data for validation and testing as well. So here we'll use that test data. And validation is, we'll look at there's something called as cross-fold, k-cross-fold validation and things like that, and we'll learn about these techniques as well. So after testing, you select some metrics based on which you will evaluate. So after in the testing phase, you will do some evaluation. So there are different metrics that will look. There are different performance scores, like there is accuracy. Then we have F1 scores. Then we have something called as precision, recall, area under curve, and a lot of metrics are there by which you can evaluate the performance. You can do that. And after this, when you sort of see the evaluation of your model and how it is performing on the test data, then you will do something called as hyperparameter tuning. Hyperparameter tuning. Because there will be some parameters which you have control over. So we'll learn about these hyperparameters in detail. So for these parameters, you'll have to sort of fine tune them so that to get the optimized performance. So you will do that tuning, and there are some methods. There is something called as grid search. So you'll perform these optimized search operations so that you find the appropriate values for these things. And after this hyperparameter, and you will again do the validation and testing of the model. So then when you are doing in this phase, after that you can deploy the model. So when you are sort of convinced that this model now performs at least better and you have done a lot of testing and validation, then you can deploy the model. So you can do the deployment of the model. So in deployment, what you'll do is you will just take the trained model and the validated model and move it in the production quality, where probably you will deploy it into some websites, or you will deploy it into some applications or some other things where you want the people to use it. So and after the deployment, you have a very important stage of, I'll not write as a separate step. So there are different steps, I'll just write them as clubbed as one step. So you'll monitor the model. Okay, so you'll monitor and maintain it. Okay, so these are the steps usually involved in an ML pipeline. So that's why it's called a machine learning pipeline. So you start with the data collection, then after data collection you will pre-process the data, and you will do a lot of things that are there in pre-processing. Then you will do the feature engineering. So you'll split the data, split into train, test, and maybe validation sets. Then you select a model, train the model based on the training data. Then you will give it, and you will test and validate the models, and then this sort of iterative process. You will continue to do it and tune the hyperparameters at the same time. So when you think that your model is optimized, then you will go for the deployment. You will deploy it on the real servers. Maybe it will be used in some application. It will be used in some website or things like that. And then you will continuously monitor and maintain the models. So each step of in this pipeline, it requires an expertise in data analysis, and some steps requires machine learning algorithm. You must know that, and some also steps involve like software engineering or automated tool frameworks and things like that. So this is sort of a brief discussion over what I call it as ML pipeline. So I'll just write it here. So this is the ML pipeline we'll be going through. And now in the first step, you saw that the three most important steps that you saw are these three steps. Because there is something called as garbage in, garbage out. If your data is garbage, no matter how complex model you use, no matter how better you are at coding the algorithms, it doesn't matter, because you are giving the garbage and the model output will be garbage. Giving the analogy, for example, it's like an environment. If a kid is born in some environment, no matter how much you sort of hit him or do something like that, because the environment itself is bad, while the data itself is bad, because the data coming from environment is bad, so he won't have the high chances of becoming a good kid. So it's better to sort of spend more time in pre-processing and looking at the data, so that when you apply the models, that time the models should perform really good. So most of the time, I think nearly 60 to 70% of time you will give on to this, because applying a model and then getting the result is sort of easy, but getting these things right is really important. That's why I chose to sort of expose you with exploratory data analysis, so you can analyze the data on your own. It's a really important step. So let's go into the EDA. So is this concept of machine learning pipeline clear? Nice. Now moving on to this first step, because now you saw what the seriousness of data, and you saw how seriously we should take data, because otherwise no matter how much complex model or how much elegant model you use, your model will not work. So for that you must have a good data, and you must have those eyes, so by which you can look at the data, and you can choose and pick these features which you feel are sort of the things that will help our model to become better. So it's also an art, and it also is a science. So there is a difference between science and art. So sometimes art is which you learn by experience, and you can explain it to somebody. And when you will do a lot data analysis, you'll feel at some point it's an art, because some concepts I cannot teach other person, irrespective of like how much eloquent a speaker I am. But the best thing is you must practice in that. So going into this exploratory data analysis. Okay. So what is this EDA? So I'll just maybe share the screen as well, so that I'll code the things which are visible. Okay. So this is the initial step that is there in the data analysis. It involves like summarizing. So it involves summarizing the data. For example, if you have a data and you want to summarize the data, and then you want to have some visual methods. So you want to produce some visual methods so that you can understand the data better. Or sometimes you want to find some structures or patterns, find some structures or patterns in the data. So if you want to do that and you want to find some relations, in order to build a model, you must know things about data. So that's what is called as exploratory data analysis. So we explore the data here. So we analyze the data and explore it. That's what is exploratory data analysis. So exploration is done so as to summarize the data, and by using the visual methods to understand the data better, and then we find the structures and patterns in the data. So why is it important? Why is this EDA really important? Why do we do this? The first thing I'll say is we are not the domain experts in every field. For example, if I'm solving a problem related to weather, I'm not a chemist, I don't know these weather well. So in order to have some understanding before applying the model, I must have the idea of what data is doing. So the first thing is I'll say why is it important? The importance of EDA. And this is really cool, and you will do it and you will love this job, and then you'll feel okay, now I know something about the domain as well. The first thing that I will emphasize is you will understand the data landscape. Understand the data landscape. By that I mean like it provides an overview of the data set. So including you have the size, how many type of variables you have, what distributions it follows, and if there are some potential problems like are there missing values, are there outliers. So this is really crucial for this, because you must understand the data landscape. So what are the things that you will learn about the data? So you learn what are the features in the data. Okay, how many data points do we have? So number of data points we will have, and then you will see if there are some outliers, are there some missing values. Okay, if there are some missing values in the data, so how to deal with those missing values. And if for example what is the size of the data, and will the data fit into our RAM when we are applying a model, will the RAM be enough, and will our machine be enough to handle that sort of data. So you'll understand the data landscape first. Is the first importance I'll emphasize. And the second thing is you will identify patterns in relationships. So now you have an idea about data, you know what features are there in data, and then how many data points you have in outliers. Then you want to see among these features, is there some relationship in the features? So is one feature impacting other feature positively or negatively? You'll find correlations, and you will learn about causations as well. So what causes the other thing? And sometimes there may be a correlation, but it won't be the causation. And you might have heard the famous thing, the correlation is not causation. So you will identify these patterns in here. So you will visualize things in here. You will make different type of graphs which we have seen how to make graphs in matplotlib and maybe in seaborn and things like that. And you will have summary statistics, like for example what is the mean value, what's the average, mean or average value, and what is the median. So how much percentage of the values are lying between this and that range. So you learn a lot of statics, and you will see the trends in the data. So for example, if you are actively involving in stock market, you will see, okay, for one company, how is stock performing. So for that, you will have to do this analysis and find the patterns and trends, and then you will have the feature selection by that. And when you have these patterns and relationships, you know that, and you will come to know there are different features which have more importance than other features, and there are some features which have less importance over other features. Then you will do what's called as feature engineering, and select the features. Okay, so you will, it will help you in feature engineering, so which we saw it is an important step. So in the feature engineering, you'll probably have feature selection and feature extraction. So we'll learn different techniques how to select the features and how to find which features are better than other features, and then we'll have feature extractions as well. Okay, so this feature engineering will be aided by the exploited analyst when you know the things about data, and then it'll be easy for us to formulate hypothesis based on the data. When we'll have an overall idea about the data, then it'll be easy for us to sort of make hypothesis, or this data is made like this, so we'll make some hypothesis and then test the hypothesis. So I'll say formulating hypothesis. So now you have an understanding of the data. So now you can hypothesize. I think this data should do this. I think tomorrow this should happen in the stock market. Why? Because you understand data well, and then you will test your hypothesis as well. So formulating hypothesis, it requires you to understand the data well. So in order to give some hypothesis and test these hypotheses, you must first understand data well. So that's why this explorative analysis, it's really important in formulating the hypothesis. Okay. So this is the importance. Why do we do this EDA? That's why I told, like, nearly 60 to 70% of the time you will look at the data, you will try to understand it. Then maybe you'll hardly spend some 10% of the time in selecting and training the model and finding the hub parameter tuning, and then maybe 10% time in deployment, and you are done with the model. Probably then deployment there will be 5% or something. So this will be taken care by the software engineers and things like that. I hope that you now know the importance of doing this exploratory data analysis, because without this you cannot understand the data well, and then you cannot make the model well. So in order to make a good model, you must understand the data really well. So have you understood what is the importance of EDA?
सर फॉर्मुलेशन हाइपोथेसिस ये रिपीट करना.
Okay, okay, I'll repeat that. So I'll give you some real world examples as well, so that you understand this. So what I'm saying is, when you understand data, so you will hypothesize. For example, in the stock market, let's take an example of stock market. So you might have seen that stock is going up. So you are, for example, on this day. So now you understand the pattern, the data, how data is behaving, and what is the company's health. Now you will hypothesize that tomorrow the stock will go up. You will have an hypothesis. Now you have to prove your hypothesis. You have to, then, because you have made a claim, and then you have to prove your claim. So hypothesizing, you have some hypothesis based on the data that you saw, based on the trend you saw, and you'll see that in the previous week I have seen this trend, and I think because of these things that this stock should go up. So you'll hypothesize this, and then you will test your hypothesis tomorrow, and maybe you'll have some mathematical formulation for your hypothesis, and then you will test the hypothesis. I think this formulating hypothesis is now clear, and there's a lot to discuss. I'm just giving you breadcrumbs as of now, because I don't want to go into mathematical details, what is called as null hypothesis, and then there is something called as, in the time series we have something ADF test, augmented decoupleur test. I don't want to go into a lot of mathematics right now, because you will see that that will be coming later. Otherwise, you will feel bored in this. So just remember the steps. So when you understand data, you will formulate some hypothesis, which will test on later. Should I move ahead?
Yes, sir.
Okay. So let's see some real world examples. Real world examples. Why will you use this EDA mostly? The first thing you might know is financial data. Financial data. So I myself am an active investor in stock markets and SIPs and things like that. So most of the times I analyze this data before investing in any stock. So when you are in the running a financial institution like banks, or you are a stock trader or something like that, for that you must understand the data well. Then you will take informed decisions. This is one of the examples. So why am I again reinforcing the example so that you know why is machine learning applicable. So then we have healthcare. In the healthcare, we use EDA to explore the patient's records and understand disease patterns. So if somebody is a cancerous patient and we have, I think, let's suppose we have 250 patients like that. So we'll understand a pattern where these people having such disease. So are there some environmental factors? Is there something wrong in their diet or something like that? And for that, we'll analyze this healthcare records and to come up with the patterns as well. So and then we have e-commerce analysis. So e-commerce analysis, like every website, they do analyze the data. For example, take the example of Flipkart, Amazon. They see the trend of the people who are buying some items from them. So then they predict what is the item that they are likely going to buy. So they analyze the data a lot. So in the e-commerce, you can also have this YouTube because it actually is an e-commerce website. So maybe they don't sell you the physical items, but they sell you their recordings, and then they sell you the videos and the content like that. And they also perform this analysis of the analysis on the data, analysis on the people, so as to provide the better recommendations. Okay. Then we have climate data. Climate data. So in the climate, you might have seen that what is the prediction for tomorrow. So you also analyze the data and analyze different features. Then you have might have seen visualizations like previous. Now there is a huge hype going around this climate change. Climate change. Why are they doing so? Because they are saying that temperatures are getting so uneven, and they might show you some graphs for visualizations and things like that. And there are a lot of other examples that I can show you and that I can give you that why this machine learning is used in the real world, and why we use this expert data analysis to make the data understandable in the real world. I don't want to go to the correlations and things like that for now. So I'll go into the stepwise procedure. So what is there in EDA? So the first thing that will go in the EDA is, because we understood the EDA and its importance, then we saw the real world examples where people use this EDA. Now we'll go the techniques of data collection. So how do we collect data? Data collection techniques. Because you have to collect the data. That's the first step in here. So because you'll be working with a good company, inshallah, in the future, and that time you will have to collect the data first. And sometimes the data collection, this step is skipped because most of the data people use some pre-built data set. But when you are working on a real-time project and you have no clue about the data, so for that you must have this data. So you must know these data collection techniques, or how to collect the data. If you see how this chat gpt works, are recently Google has released a large language model which beats chat gpt. I think its name is Gemini. So they have also trained it on some data, so they must have done this data collection. So they have collected the internet data. And how they have done it, the first thing people usually use is they'll use web scraping. So then this in itself is a huge field, how to scrap the web and how to take the data and make it more understandable. So this is the thing that you'll do. So sometimes you'll scrap the web, and but consider the ethical considerations. It's crucial when you scrap the data and you adhere to the website's terms and services. So when you scrap a website, you're taking the data of the website, so you must consider these legal ethical aspects. Otherwise, like there are laws, something called as GPDR, which may impose some fines, and they are imposing fines on the companies as well who are unethically using the data to for their own benefit. So when you are scrapping the web, make sure that you sort of read the terms and conditions of the website and how to scrap it and what is allowed to scrap. And there are a lot of scrapping things that I think that's not a part of this course, but you can see, and you can read a lot of material on that. And there's something called as beautiful soap, selenium, and things like that by which you can scrap the web. Then you can do the data collection from, that's called as APIs. You have API calls. For example, you have different repositories where they keep the data, and then you will make just an API call to sort of call the data and load the data. So this is called data collection by using the API integrations. So this I'm saying when the data is available. So this is when data is available. Data is already available because somebody has collected the data for you. Now how do you collect from them? So maybe there is a data on website and you want to scrap that. And sometimes people have kept the data repositories, like there is a famous repository called as UCI repository. So many people, they import the data from there. So this is the data when the data is available for you. But there are other methods, for example, when the data and when you are solving a new problem. Let's suppose we want to train a machine learning model so that it detects whether a patient is diabetic or not. So for that, we'll go to the patient. So the other method I'll write here is you'll do surveys. Okay. So you might have even read that a survey was done on this, a survey, and they basically take physical patients and they agree to these terms and conditions, and then they give the data on purpose. So these surveys, you will maybe float some forms to take the data, and maybe people will sort of give explicitly their outputs, and they want to maybe test on something. So in those surveys, you collect this whole data on your own. Okay, so you might have seen science people, they are floating some forms, we need some people for this experiment, are the people willing, and they're willing to pay money for these people as well, if we have to run an experiment. So for this you can also collect the data in this way. Okay, so float the survey forms, maybe have some population the people which will fill in some forms. Okay, this is how even the forms, this is called as explicit data collection. Data collection, basically you're explicitly asking people to give the feedback. And in the YouTube as well, you might have seen there is a like button, people have to interact with that. So they have to give the feedback, or people have to sometimes fill the forms. So when I, for example, started this course, I floated different forms so as to collect the data. So I floated these survey forms to collect the data. And then there is something called as implicit data collection. Implicit data collection, you must know all of these methods, because when you will be working in a company, there you will have no clue about the data sometimes, because there will be no data will be available to you for that. But when you know these methods how to get the data, so you have at least a broader overview कि यहाँ से ये data मिलेगा, इस data को ऐसे ले सकते हैं, and then maybe we'll go on the cleaning of data and stuff like that. The first step is how to collect this data. So what is this implicit data collection? This is because you are now, the user is not interacting with the data. Now user is not just giving you the explicit feedback. So here user is making some actions, or perform or doing something, or maybe doing some task. So then you implicitly take the things, like for example, if you are seeing a YouTube video, so there what you are doing is we are seeing how much duration is the YouTube video. Let's suppose we have a YouTube video of 15 minutes, and if the user is changing the video after maybe 2 seconds, so he clicked on this 15-minute video and he changed the video to other video in within 2 seconds, so we are saying that the user has not watched this video, and it was not interesting to him. So from that we got to know that we should not recommend these sort of video to the users. Let's suppose it was a movie video, and when it was recommended, user clicked on it, and then within 2 seconds he just closed the video and moved on to some other video within 2 seconds, and then it was a maybe 15-minute long video again, and then it was something, let's suppose a lecture on Python. So in that he spent, let's suppose, 10 minutes. So here he spent, let's suppose, 10 minutes, and here he spent 2 seconds. So we got to know that we should not recommend that guy the videos which are maybe movies, and we should sort of more recommend these videos, because now user hasn't given the explicit feedback like he liked the video, or he commented on the video, something like that, or he filled a survey form. But what he did is he just performed some action, and by the help of which we made an inference. And there are a lot of things like that on the basis of which we will make inference. I just give an example of YouTube, how YouTube might recommend you the videos, because you are giving more watch time to these videos, so YouTube will be recommending more videos like this. And now we have I think Google even has this microphone access always, so when you speak about something, so it collects the data, and if it sees the word being used frequently, then it will pop up some ads related to that, pop up some videos related to that. That's what is called as implicit data collection, because you are not giving the feedback explicitly, you are not filling the survey forms, but what actions you are doing, based on your actions are the tasks you are performing. So we are recommending you the videos, or maybe the ads, and things sound like that. And for this surveys and things like that, you must have these domain experts which will tell you which things to take, and domain experts are necessary. I think I had this discussion previously with you. So domain experts are really important in this, because for example, let's suppose I'm not a doctor, so if I have to study any medical case, because I don't have the prerequisites to understand that thing, so for that these domain experts will help me to understand the data. Then maybe I'll understand data better, I can create a machine learning model. So this is how we collect the data. That's the initial step of collecting the data. Do not take this for granted. This is a really important step, because sometimes you will be stuck with a problem where you don't have data, and for that time you have to create your own data. And most of the projects that you will see online, like people bring the tutorials because they assume the data exists sometimes. But the most important step is this: where to get this data and how to get this data. I just gave you some of the examples. You can scrap the web. There are API integrations. You can have the survey forms, and you can maybe take this implicit data collection, explicit data collection, and things like that. Is this data collection step okay? How to collect this data? Is this sort of clear? Okay, nice. Now we have the data. Okay, so because I have to understand, I have to make you understand how this EDA works, so we also have to collect the data. So in the data collection as well, there is a sub problem. That is the thing. So how to, first of all, you should know what problem you are solving. Okay, though, so you must define a problem first. Keep your focus here, because these things are really important. I don't want you to be a developer or maybe a data scientist who just imposes statements. I want you to internalize these things. So first, in order to do something, you must define a problem, what I am doing. So for that, you will first identify the problem. Identify the problem. So what is the problem? So clearly define and ask the question. So what am I going to address with this? So you understand the scope of your problem and objectives and potential impact on this decision. Let's suppose in today's session we'll be working on what is called as, there are different flower types. We'll go into that data set detail in some detail, and it basically we have data about some plants, and then we have to predict. It's a prediction task. We defined the problem. It's a prediction task, and we have to predict what type of flower it is. What type of flower it is. So I'll be just loading some data in which I'll have different features, and based on the features, I'll have to tell you which type of flower it is. Because being a if somebody is working in field of botany, they see flowers which are looking like similar, but they have named it differently. So what is the relations between that? What is the relation between these different features? So they have collected some features. Based on these features, they'll assign some class to it. So they'll assign a class. So now we know the problem, and we have clearly defined a problem with a question that we aim to address. And then we understand the scope of it. Whom will it help? It will help botanists, for example, because botany people, they sometimes are confused which flower this is. So based on this, if I am able to create a machine learning model which can predict which type of flower it is, so it will be easy for them to categorize these flowers, because there are millions of species. So we have now identified the problem, which are the scope. Then we must know the data needs. So how what data to tackle. So data needs, I'll say. So what type of data do we have in the features? What are different features, and what are the data types? Is there a string? Is it a float? Is the numerical type data type, and things like that? So when you know that, now you have to find the data source identification. So I think define the problem. Now you are done with this step. Let's suppose you are done with this. You defined the problem, you identified the problems, and you saw what the needs of our data. Then you will have this data source identification. In this, you'll have two sources. One's called primary source and secondary source. I have seen many people omitting these things when they are going to teach machine learning. So what I have seen frequently is they omit this part because they assume the data is there. But when the people go into the real world projects and they're assigned some tasks, and if they have no clue about this, they struggle a lot. So for that, you must know where to collect the data, how to do this. So now the primary sources, they are from survey forms. You take the interviews, experiment, observations that we saw, like the explicit and implicit data collection. And I'll just write the few names here, and you can maybe have survey forms, and then maybe you can perform some experiments to collect the data, and you can have interviews with the people and things like that. And these are the primary sources. What are the secondary sources? Secondary sources are, you will just go onto some government database, or maybe have some research papers where you have not collected it yourself, but it has been collected by somebody else. So this is secondary source, in that you might have some databases which was not collected by you, and but you have to put your trust on that, and you'll get the data from that. And maybe there are some research papers published, research papers and the things like that which you haven't directly collected. Primary source mean that where the problem solver, whoever is solving the problem, he is collecting the data directly by using survey forms, maybe performing some experiments and doing some observations or things like that. And then the secondary sources where you are not collecting the data on your own, but there is some data, for example from some reputed government organization, there is a database, and then there are some research papers, or maybe some APIs are there which we saw how to collect the data. So now you define the problem, you identify what's the problem, you saw the data needs, what's the data that I need. Then you have to find the data sources, what are the source of data that I'll do. And then you will collect the data according to your strategies, and maybe after this source identification you will do the collection of data. When you collect the data, then you have to do other steps as well. And but very important thing is consider doing it ethically, because otherwise I told you there are some laws called as GP, and even now we are being in the era of AI and they are making some AI ethical laws. So keep this in mind, so it should be ethically, otherwise what are the model you will make, and if you deploy it somewhere more than earning, you will be in losses. So it's really important to respect the privacy and the consent of the people. So if you are collecting the data from the people, so you might even see you might I just had a chat with a guy and I recorded his video because I want to post that, but that guy was pretty uncomfortable after I told him, so I had to remove that because of the privacy concerns and the consent. So adhere to these ethical standards and legal regulations regarding the data privacy. So you ensure that you compliance with the laws like GDPR, and there is some other laws called as HIPAA, and so that you obtain the necessary consent while collecting the personal or sensitive information, because it's really important to adhere to that. Then use this data ethically. So when you collect the data, and if you have no consent and you respect the privacy, but you must use it ethically so that you respect the user's privacy, avoid the misuse. And there are a lot of case studies where the data has been misused, and then a lot of problems happen to those individuals. And I would like to discuss these case studies, but I'll emphasize you, whenever you're working with data, just make sure you are doing it under ethical constraints and you adhere to all the laws. Okay, and then you will have this continuous improvements. The first thing is, now we'll go to on our own data set to see what are the things that we'll be doing with the data. So I told you we have this iris data set. Let's go into that and I'll show you in the code window how I'll get these data. So I have written it somewhere. Yes, there's a lot of details that I usually write in my notebooks so that you can use it for the later period of time. So the first thing is we'll be using pandas. So this is the pandas that we'll be using. I hope the screen is visible. So this dataset actually was in the UCI repository. If you see in here this URL, so in here you see that I can collect this data by using this UCI repository, and I can just make a call and make a query and go to this data. But what I have done is I have just downloaded this data. Otherwise, I can just use this API integration that we saw. So by using this, and then I can read the CSV. But I have downloaded this data from the same website. So first thing is I give the path where I have stored this data. Then the column names are there: sepal length, sepal width, petal width, and then I have a class, and we will have a discussion over that. The first thing is I am reading that data. Now I am reading that in iris data frame. Then I am calling this pandas pd.read csv and giving the path and the column names. Then I am printing the head. Now I would like to discuss the things with you about this data set. So there is something called as sepal length, sepal width, petal length, and petal width. So if I want you to show about this, what is the sepal length, what is this petal length, maybe I'll just search about this sepal length, because I'm no way, by no means I'm an expert in the botany. So let's go to a flower image and I'll show you an image. I think this here it is visible. So now you see this, we have a flower like this. So this is the petal. If you see on the screen, so this is the petal and it has a length and the width. Then we have this bigger sort of like leaf, I'll call it, but it's called as this is petal and this is sepal. This sepal has also a width and the length. If you see it in here, is the concept of sepals and petals clear at least? Because by no means we are botanists, but we'll just try to get a brief overview of what is the meaning of a petal and what is the meaning of a sepal. Is it clear? Can somebody speak, because I cannot see the screen? I have just opened this Chrome. So we have this flower. So in this flower, you saw that we have two types of leaves. One of these smaller ones and one of the bigger ones. So if you take a smaller one, it's called petal. If you take this bigger one, which is at the bottom, So it's called as sepal. So we have the length of sepal and the width of sepal, and the length of this petal and the width of this petal. That's the data we have in our hand. Then we have these classes. Each of this data point, it belongs to a class. So I'll switch the screen so as to write some things. So here what I have is I have sepal length, then I have sepal width, then I have petal length and petal width. Then I have a class. Okay. So each of these have some values, and then this class, there are three types of classes. I think they are setosa, virginica, and versicolor. So I'll just write them: setosa, virginica, and versicolor. There's a famous story I told somebody, like, why are you studying computer science? Because of this, because I cannot remember these names. Now I'm at least I don't have to remember these names. So computer science is much easier than this remembering these names. So these are the classes that are there in the flowers: setosa, virginica, and versicolor. And there are different, you know, that these things which we have written over here, they are the features. This is a basic data set that we'll be working on. There'll be more advanced data sets, but I just want to give you a feel how to perform this data exploratory analysis. The first thing we have is we collected the data. How did we do that? We made an API called UCI API, UCI repository, and from that we got this. That this is called as iris data set. Okay. So now we are trying to understand the data. The first step in that is I want to show you the features and how data looks like. Each of this, each of the row here, we call it a data point. Data point. Okay, or sometimes we call it independent independent variables. Independent variables. Because all of these are independent. They don't depend on each other because we collect them. And this class is called dependent variable. See this class, this is called as dependent variable. Sometimes called as label as well. This is the data and we have the corresponding label as well. And all of these can be called as variables, and each of the point is called one data point, or they're called independent variables. And then is there something else that I want to talk this data? I think this data is now clear. You understand the sepal length, sepal width, petal length, and petal width. But when you will be working on real world data, you have to do your own research on the each feature that is being there. So if you are working in the medical field and you want to know what is blood pressure, so for that you must know what's the range of blood pressure and the things like that. So here now I have sort of given you a brief overview of what sepal length, sepal width, petal length, and petal width is. Then I have also told you about the classes or labels there are. So it can that flowers can be of three types: setosa, virginica, and versicolor. These are the classes or labels that we have. This is the data we'll be dealing with. So we now have understood some, at least have some understanding of the data. So if I just print the head of this, so I'll just make sure, and you saw these the features. So 5.1, we haven't seen the unit, so but it's okay. The first step in this is now, after we have read the data, is we want to understand the data. So in order to understand, first thing we will see is how many data points do we have in there. So for that, as you know, that there is a function of shape in the data frame, so we'll use this shape. So in here there is a method iris data frame dot shape. So if I run this, so it is 150 comma 5. So can anyone tell me what is the meaning of this 150 comma 5? Anyone? Till there I'll drink some water. So what is the meaning of 150? So 150 basically data points, 5 features. Okay, now we want to see what is there in the columns. So you also know that that's why we have seen this pandas, and we spent a good amount of time in understanding these frameworks, in understanding these libraries, I'll say. So now we will just call this iris.df, irisdf.columns, and it will give you the list of columns. So you saw that we have sepal length, sepal width, petal length, petal width. Then we have class as well. Okay. Then you can also print the head and the tail. So by using the head and tail methods. So if I call them, you know that we'll get head and tail. This is the head, and this is the tail. Okay, and the other thing now I want to see, because now I have 150 data points in here. So I told you there are three classes in the data, and what I want to see is what are the types of this data. So if we have these five features, what are the types of these features? What types of values are there? So I'll just call this the types. So we know that the sepal length is now, it's a float 64 type. Again, all of these are float 64. Now class is an object. Okay, so you can do that, and then you can also summarize the stats, and you, so that you can see the mean value of sepals, and you can call this function describe. I am purposefully not going into the details of these functions because we have covered these functions detail where when we were looking at these libraries like pandas, matplotlib, and today we'll be using all the libraries, numpy, everything that we have seen so far. Most of the libraries will use them. So I'll describe this. So you see the sepal length, there are 150 points, 150 points, 150 points. The mean value of the sepal length is 5.8, average value basically. The average value is corresponding written in here. Then we have this standard deviation. So this is 0.28 to 0.4 and thing. Then we have minimum values like this. This is called as 25% percentile, 50 percentile, 75 percentile, then maximum values. So you can understand data from here. So what's the maximum value, what's the minimum value, okay, so what's the average value, what's the deviation, how many points do we have. So there is the method, this describe method is there. Then for each class I want to see in each class how many data points are there. So for that I'll write this iris df, and then I'll say class and dot value count. So you have seen all these functions in the previous sessions. So and I want to print the class counts, how many points are there in each class. So if I run this cell, you see that there are 50, 50 and 50 points in each class. So I'll again discuss some things called as balanced and unbalanced data sets. So we have different types of data sets when we collect the data. So data sets, in this we can have what's called as balanced data set, and then we have something as unbalanced. As we saw, we had three classes, and in the three class the points were more or less similar. So in the class 1, class 2 and 3, the number of points were 50, 50, 50. Here exactly they were same. So we call a data set balanced if the number of points in each class is more or less same. So that there can be a difference of 5 points, 1 point, 2 point, but for let's suppose 49, 51, or let's suppose 50. So this also will be considered as balanced data set. So in each of the class, if the number of points is more or less same, that is very uh, sort of less. What I can say is they differ in very less points, the number of points. So points, data points in each class is more or less similar or same, not similar, same. So if there is for 49, 51, 50, so this also can be considered balanced. Then there is an unbalanced data set. So this frequently we have to deal with this as well, and there are different techniques by which we deal. And these subjects will read in a lot of detail. But what is the meaning of unbalance? If we have classes like 1, 2, and 3, and in the first, let's suppose 1, 2 classes. So in the first class we have some 50 points. In the second class we have some 10,000 points. So you saw a clear imbalance in this because in the class second we have 10,000 points, in the class first we have 50 points. So these things do occur in real world. Let's suppose we are working in the medical domain, and in the we have 50 patients, let's suppose, who have cancer. And you know the most people, they are healthy and they don't have cancer. So we'll have most of the people non-cancerous people. So this is an imbalanced data set. When we're working on this, so there will be imbalance, and you will have to deal with this imbalance. Deal with the imbalance. Okay. So the data set that we have, it is a balanced data set. So now we got to learn about the data set. This our data set belongs to this balanced because we have Setosa, Virginic, and Versicolor. Each of these classes have equal number of points, 50, 50, and 50. Okay. Now let's suppose I want to sort of deal with the statistical properties, and I want to look at, as you saw in here, this is for everything, this sepal length, sepal width, and we saw this describe method. If I want to separately print it, so there are some functions like this describe for each of these. So we can apply describe method on each of the separate columns that we have to get the details that we saw in here. So these are called to know the statistical properties of each of the column, each of the attribute, or maybe each of the feature that we'll call. And that is something you can also find the correlations. As of now we haven't seen what correlations mean, and in the future videos or future sessions when we'll be working with the stats and probability, and you'll get to know what correlations mean, and that time we'll find the correlation between the columns as well. Okay, is it clear till now what we have discussed about the data set that we are working with? So how many data points are there? So how many data points are there? At least you should have an understanding. So how many data points? Anyone?
Or 150.
150 data points. So how many features are there?
5.
So how many features are dependent features? Dependent, or maybe we call them label or class.
One.
Only one.
1.
So how many features are independent?
Four.
So four features are independent features. So at least we understood this, and then you don't need to remember the what is the standard deviation, what's the mean, what's the 75th quartile, and things like that. But at least we know till this we know the details about a data set. Now the thing is we have to prepare this data for the machine learning model. That these methods are called as data preparation or data pre-processing and preparation. We'll call them data preparation and pre-processing. So why are we doing this much of hard work? The only thing is because I told you if the garbage goes into the model, the garbage will come out. Garbage in, garbage out. Just remember this mantra. So what to do in that? So in the data preparation, what do we do? The first thing is we'll clean the data, data cleaning. Data cleaning. This our data set is really simple, so many other techniques that I'll discuss may not be applicable to this data set. But I hope that you learn these techniques, and when given the assignments or problems, you will sort of try to implement these techniques on your own. The data cleaning is the first. In the data cleaning, the thing that we'll be dealing first, we'll be dealing with missing values, handling missing values. So in the data, if we have some missing values and you want to deal with those missing values, and we have seen different functions in the pandas, fill NA, drop NA, and things, if you remember them. The first thing is, are there some missing values? So you must have, try to handle them, and how to deal with this and impute the data and use some advanced techniques. We also went through them, known as interpolation or maybe machine learning based imputation. There are a lot of, I think we have seen that interpolation, mean values, and drop these values. We have seen different methods of handling the missing values. In the data cleaning step, you must the first step you must look for is, are there some missing values? So you have to deal with the missing values, because if there are the missing values and you are giving it to the machine learning model, won't be able to perform better or won't be able to train better because there are missing values. So a priori you must handle these missing values. The second thing is, you must see if there are duplicates, then remove duplicates. There are functions as well in the pandas where you can just check the duplicate, are there the duplicates. So this is the thing, first you should do this. You should handle these missing values, you should remove the duplicates, and sometimes what you need, you may rename the columns as well. Okay, so you can rename the columns, rename columns, because sometimes the column names that there is in data, so they may not describe the things that we have. Maybe they have written it 1 2 3 4 or things like that, and you will rename so it is describable, and when you are looking at the data, it is easy for you to identify what this feature is. And as you saw that in our data, this data is really simple, and we don't have to deal this missing values there. We don't have to deal with this duplicates and rename the column, but you can do that. Okay, then what we do is you do something called as data transformation. That this is the first step. After the cleaning, you will do data transformation. So what is the meaning of data transformation? So the first thing that you will do is, suppose you have this data, and in the data some values are in the range of, let's suppose, 1 to 5. Like, let's suppose feature 1 is in the range of 1 to 5, and then we have feature 2, it's in the range of 2000 to 5000. Okay, so now you see, if you are making a machine learning model, you will see irrespective if this feature is unnecessary, but it will still have the impact because its values are bigger. So in order to remove that thing, in order to remove the effect of bigger values, we do something called as normalization and standardization. We'll go into these detail into these techniques, but I want you to know these techniques first. So we'll do something called as data normalization. Data normalization. Okay, to bring the value basically between 0 to 1, we'll bring it in the equal scale, and we'll see the details of all these things. And then we have data standardization. There are different normal, min max normal. There is a lot of things that we'll discuss in here. Data standardization. Standardization. Okay, we'll do this. Then this is sometimes called as feature scaling as well. Both of these techniques, they're called feature scaling. because you are scaling the feature. Some features are really have larger values and some features are really smaller values, but you have to scale them accordingly so it does not put an impact. Okay, let's suppose where will this impact? So if we see this heartbeat, so how do the persons usually range, let's suppose from 60 to let's suppose 100 in beats per minute. But if you let's suppose take the uh, value of ECG or the value of this blood pressure, it usually is higher than this. It ranges from let's suppose 90 to let's suppose 140. And if you have blood cholesterol levels, and then let's suppose it is from 200 to 400, you saw that these are different values are there. But you want to these features have homogeneous impact. You don't want to if something has a bigger value and it should impact our output more. So for that you will perform this what's called as feature scaling. Okay, so we'll look into that in the detail how to scale these features. So this is the data transformation part. So we are in this stage, data preparation and pre-processing, how to prepare the data, so and how to transform this data. So in the transformation part you saw normalization, standardization, and this called as feature scaling. Then you have encoding. There's something called as encodings. Sometimes what you need, if you have the string data, if you have the data that's in textual form, and you have to transform that. If you have some data which is in the audio form, which in the video form, and you have to transform that, because computers don't understand video directly, and you have to make them into the numbers. At the bottom level of the computer, it understands numbers only. So you have to write these encodings. Okay, so you have to encode the data. Okay, there are different types of encoding that we'll learn. Okay, and sometimes in the classes, if you are doing a classification task, then you have to encode these class labels. So this is encoding data, specifically the features that I was talking till now. Encode the features. For example, if you have audio, so how to sort of give this data to the computer, and you convert this audio into what is called as spectrograms. And spectrogram, they're just bunch of numbers. And if you have an image, because computers won't be able to understand image, so you have to transform it into the pixel values. I'm just giving some rough examples. And if you have, let's suppose a text, so there are different techniques, and some simple techniques are TF-IDF, term frequency, in inverse document frequency, and we'll look what these things are. Will this topic is a separate subject in itself, encodings. So we'll learn how to encode this data, how to encode these features. So if data is in numerical form, so maybe we don't have to deal, and we can sort of tinker here and there. But if data is in audio form, image form, text form, we have to understand that we have to make spectrograms, pixels, and for this textual, use some techniques like TF-IDF. There is something called as CBOW. Okay, and there are some other things like there are techniques like glow and things like that. And this thing comes into natural language processing, NLPs. Okay, these two things come under computer vision. Everything falls into the AI, but when you are dealing with audio, image, and it mostly with the image, you call it we are doing computer vision. When you are dealing with textual data, which may be in Hindi, English, Sanskrit, and whatever it is, you call it we are doing natural language processing. So you have to encode these data features. You have to encode the labels as well. Sometimes these labels are discrete. Encode labels. Okay, encoding labels, as you saw that we have 4 classes, right? We have 3 classes. So there are different encoding techniques. One is called as one hot encoding. I just want you to know the terms, so we'll be going into the detail of each the term. One hot encoding. So what is this one hot encoding? Just giving a brief overview. So as you know that we have 3 classes, we'll make a vector of like 3 rows. So let's suppose the first is setosa, then we have virginica, then we have versicolor. This is virginica. So if the flower belongs to the setosa, so we'll put 1 over here, and the rest we'll put 0. That's why it's called one hot encoding. So if there is a particular class which data point belongs, there we'll put 1. For the other values we'll put zeros. Okay, so if we have, let's suppose, k classes, in the k classes, if a data point belongs to, let's suppose, ith class, at the ith value we'll put 1, and for all the other things we'll put zeros. So this is called as one hot encoding. Okay, then we have label encodings as well. So here, then we have label encodings. Label encodings. So in the label encoding, The thing we have is, let's suppose here we have only three classes, so we'll represent them by 0, 1 and 2. So these are three classes. This is the labels. So telling this is Setosa, this is Virginica, and this is Versicolor. Is the concept of this clear? How do we transform data and how do we make it machine understandable? That's what I mean by data transformation. And then we have last thing that I would like to tell you what is there in this data transformation. We also sometimes use what's called a data discretization. Data discretization. Spellings can be here and there. So what is the meaning of that? If we have continuous value, so let's suppose we are having these stock prices. So in that we have these continuous values at each second, at each millisecond. But we want to discretize them. We want to change a continuous value into some discrete values. So we have techniques for that, by the help of which we convert this continuous data into discrete intervals and for the specific requirement analysis. So till now we have seen in the pre-preparation and pre-processing we do data cleaning and then we do data transformation. Are these two concepts clear? Okay. Umar was suggesting that we should take breaks in between. But when I go in flow, I don't remember the time. Do you want a break? Do you want a break of, let's suppose, 3 minutes? Nobody wants a break. So should I go ahead?
Yes, sir.
Nice. So now we are discussing about the data preparation and pre-processing stage. And we'll code these things as well. Don't worry about the coding part, we'll also code. But know that these things do exist there and you must know how to clean the data, how to transform these things. And then comes the other step in the data preparation step, that's called as data reduction. So data reduction. Data reduction. So what is the meaning of this data reduction? So sometimes you have features, there are thousands and millions of features, but what you want your machine learning model to be a little bit simpler than that, because you know that many of the features they are in vain. They don't have this impact over the output label. So it is better if we can remove these features, if we can do the combination of these features. So by this data reduction, I mean that reducing the number of features. So we can reduce the number of features. Reduce number of features. So if there are ways by which I can reduce the number of features, and there are techniques which I called previously, that are called PCA, Principal Component Analysis. Then we have TSNE. There are a lot of things that we'll learn about this, but know that by using different techniques, we'll be able to sort of make these features less, so that to make our data less complex. So the reduced number of features is the one thing that you can do in the data reduction. Then we have sampling techniques. Okay, and sampling techniques. So what is the meaning of the sampling techniques? So sometimes you create smaller representatives. For you have huge data set. For example, you in there you have 10 million records. But you know that if I have a smaller subset of this data which I can sample, and I can create a pretty much like similar model that I can create with these 10 million records. So it's better to have this subset of this data. So that's what's called a sampling. By sampling I mean take a subset of data which you feel is better and it represents whole the population. So there's a concept called as population. We'll see all of these concepts in when we'll be reading about statistics. So population basically means the whole thing that we are considering at once. But if you take a subset of that, we call it a sample. So population means everything in there. So if you are working maybe on rain data, so if you have data from the day one when the earth existed till now, this is the population. Then if you sample some days, so if you have a subset of this data, maybe 100 days, 200 days, so we call it a sample. Okay, similarly if you have this whole blood in your body, so it's called this is whole population of your blood. Then if you take a small one syringe of the blood, we call it a sample of the blood, because we don't take whole of the blood, we just take some sample, some subset of that. So in here Sampling technique is if you have huge number of records, if you have a lot of data, but but you have the instinct that if I train my model on less amount of data and this sample represents basically the population, so it is better to take the subset of the data. So for that you have to use sampling, and there are a lot of techniques in sampling. Okay, so in order to also deal with this unbalanced data set, you do what's called as undersampling, oversampling, and we'll see that as well. So but remember that in the data reduction, what we do is reduce number of features by using different techniques like PCA, TSNE, and we'll also use sampling techniques by which we'll sample a subset of the data. Okay, after you are done with this, then you must handle the outliers. You must handle outliers. Okay, this is the data what we do in the preparation and pre-processing. So let's suppose you are doing something and you saw the in the age column. Let's suppose you are dealing with the patient data. In the age column, usually the age lies in between. Let's suppose 0 to the max age that I have heard is 140. So this, and if you saw some person aged as 1500, if he's a ghost, अगर तो वो जिन था, तो that's a separate question. If you are analyzing the data of demons, so that's a separate thing. But here you clearly see that this was a mistyped value. So this is an outlier. So this was mistyped. This basically an error, not an outlier even. So the outlier is if the usual average age is 75. If somebody has lived for 150 years, it's a real data point, but still it is not represent the normal value. So we call it an outlier. So what is the outlier? Which is actually out of the norm. So the age normal generally should be between 0 to 75. The average age is 75. But if you saw some people if you saw a person whose age is 150, you call him an outlier. Okay, so you have to handle outliers. If there is a data which has at, let's suppose, 2 3 4 outliers, how to deal with these things. So you have to do that as well. So identify these outliers, and then what is the treatment you are doing to these outliers. Do you trim the values and do you cap these values? So because these things make transforming skewed. So let me give an example so as you understand why do we have to handle these outliers. Let's suppose we are let's suppose we are collecting mangoes. Everybody among us is collecting mangoes, and we want to, let's suppose we have five people, 1 2 3 4 5. So if you see, if each of us, and let's suppose I am collecting 10 mangoes, somebody is 8 12 14 13, something like this. If you see the average value of this, if you compute the average value of this, so this is 10 plus 8 is 18, 18 plus 2 is 20, 30, 40, 44, 54, 57. So 57 by 5. Okay, so the average here is somewhere around 11 point something. Okay, so this is the average value, 11 point something. But if there was an outlier, let's suppose among this 5 members, if this guy he collected, let's suppose, 120 mangoes now. So if you now compute the average, so the average will be very much higher. So it will be, I think, more than, if 120 plus, let's suppose, 50, so 170 divided by 5, it will be more than like 30 plus. So you saw the impact of outliers. So the average was 11 point something if we take the normal consideration. But if there was a guy who collected a lot of mangoes, 120, so he became an outlier in that because he impacted many statistical properties. So impacted these things. So that's why we have to deal with these outliers because they impact our results. So we should not consider this as normal. If somebody is having the data which does not look like normal, so you have to deal with these. So is the concept of handling outliers clear? Nice. So then we have the data integration, merge the source, merge the data in the different, and then we have what is called as data integration. Data integration. So if you have to integrate more data, if you want to make your model better, sometimes your data is so small and you want to integrate more data. So for that, there are techniques for data integration, compiling data from different data sources and things like that. And we've also discussed data normalization when you and standardization as well in here. In the transformation part, you have seen that. And the feature engineering, you have to select features and will write feature selection or feature engineering. Feature engineering, you have to do that as well. And then you have to handle imbalance, which I talked earlier. Handling imbalance. Handling imbalance. So balancing classes, and then you have to partition the data, and then if this data is time series data, you have to make it stationary and things like that, and there are a lot of steps involved, but more or less I think these things are sufficient to know. So in the preparation part we do the data cleaning, then you transform this data. So after this data transformation, what you will do is you will have encode the data sometimes, and then you will have to discretize data in the transformation part. Sometimes you reduce the data, and you have to handle the outliers, handle the imbalance, and also integrate the data from different sources and do the feature engineering. So these are the things which are broadly in there in the data processing and data preparation stage. So how many of you are confident at least that you understood them till some extent? I don't want you to tell me that I understand them fully, because you will understand them when you will do some real world sort of project on this, and then you will understand them fully. Nice. Okay. Now you'll go on the data cleaning. We'll see how to deal with the missing values, and we'll go onto the coding screen to see that. We'll go onto the coding. Yes. So I think here we have this. So we have this is null value. So we want to see, are there some null value, are there some missing values in the data frame. So you saw that in our pandas we have this function as is null dot sum. I want to see how many values are there which are having the null, because you know that there is no null value, but in the real data set you will have that. So I'll just run this cell. You now saw that in the sepal we have zero null values, in the sepal width we have zero, petal width we have no null values basically. So how to remove this, how to do the imputation. So I have also written a code line for that. So you can just do this iris df if there were, but there are not, so it will throw an error. So we'll say fill na. Fill na means fill these null values. What should I fill it with? Fill it with the mean. So fill it with the average value. So you saw the average value for here. So if I again write this df.describe, and you'll see the average value for sepal length, sepal width, and petal length and petal width. So if you have some null values over there, just fill it with the average. And there are some other methods that we I think discussed, like methods like interpolation, drop these values, and things like that. You should see the pandas video for that. But here you saw how to deal with these values. This is called as imputation. What is the meaning of imputation? Filling the missing values with some mean values of each column. Here we are doing that. We're doing that. The imputation is basically filling with the mean values. If I run this cell, it will just throw an error because there are no null values. So as you saw there, then I told you have to remove duplicates as well. And in order to find the duplicates, what you write, you should write this function basically removing duplicates. You should write this drop duplicates. There are functions by which you can first see if there are duplicate entries. So here I'm just writing the direct function of removing these duplicates, as the pandas provides with the function that's drop duplicates. I think there is no duplicate here. It won't make an impact. So it made no impact basically. Okay. And if you sometimes want to drop a specific column, so sometimes you see that I have to select the features and the column name, one column is not necessary for me. So you'll write iris and data frames name, then write drop and the column name. And axis basically means you are doing it horizontally. Axis 0 means vertical, axis 1 means horizontal. And in place basically means do it in the same data set. Do not create a new data set. Okay, so you can drop a column name in there. So this is what is called as feature engineering, because you want to remove some features, or you sometimes want to add some features as well. So you can add the features as well in the data frame. So again, you can drop based on some condition. If you see this, you can drop the based on the condition. So in that you will write this iris df. If the column is not equal to some specific value, then drop this. So dropping on based on some specific values. We have seen all of this in pandas. I just wanted to tell you how to do this with our data set. So here I haven't given some specific values. Is this clear? Like, is this clear how to remove these duplicates and how to find these null values and how to deal with these null values and things like that? Is it clear? Because there is no imbalance and we won't be going how to encode these things. As I told you, our data set is pretty simple. It is not that complex. So it is easy for us to just do some random, not even random, do some little bit pre-processing and then get the data in a clean format. But you now know there are a lot of techniques by which you can transform your data, you can clean and things and do things like that, so as to make your data set, prepare your data set well for the machine learning process. Okay, now we'll analyze the data. Now we'll perform what is called as univariate and bivariate or multivariate analysis. So we want to see different plots and things like that we have seen in matplotlib. So now we'll go on to the plots. Now we understood the data and we saw there are different features and things like that, and now we'll understand the data with the help of plots. Okay, So how many of you can tell me the goal? What is the problem that we are solving? What is the goal? Maybe I'll call out a name. Jahangir, can you tell me what is the goal of the problem that we are dealing with here?
So first of all, we are cleaning the data,
A goal,
and
goal of
we
the
are
problem. Goal of the problem. There is a problem that we are dealing. Basically, we want to predict the class of flowers.
Class of
Nice. So this is our goal. So now we have data. We clean the separate thing. So this is our goal. So in order to achieve this, we are trying to understand the data better, and we are doing what is called as exploratory data analysis. We're exploring the data now. We're in that phase. So we'll explore that with the help of plots. So we'll go and make some plots to understand the data better. This is the scatter plot. Okay. So I'll make the scatter plot by using the matplotlib library that I have introduced in the previous sessions. I hope that everybody will be able to understand this easily. So what I'm doing is I am just creating a figure of the size 8,6. So then what I'm saying is I'm saying plt.scatter, like make a scatter plot. What in the scatter plot, you know that we must have two values, the x-axis and the y-axis value. So here I am making a scatter plot of sepal length versus the sepal width. Then I am giving it the color blue. And alpha, you know the transparency value, I am giving it 0.7. Then I am giving the title, the label, and the y label, and then I'm giving a grid and show. So if I'm sort of printing it, you saw it on the screen in here. So clearly, if you see these tick marks, you know that these are called tick marks. I have explained you these graphs as well. So the sepal length values, it roughly starts in the range of 4.5 to 8.0 if you see this. So sepal length has the values from 4.5 to 8.0. So then we have the sepal width, it has the values from 2.0 to 4.5 if you see it here. So these are the scatter plots. You saw that, you know the what is a scatter plot. I haven't written the definition of scatter plot over here. So I told you we want to, if you want to find the relationship between some different between the features, so we can use these scatter plots. Here we want to see if there is a relation between the sepal width and sepal length. So you saw, like for example, clearly in this picture, if I draw a line from here, if my cursor is visible, if I draw a line from here to here, okay, so I can separate out these points. This is the bunch of points which I can separate out. So maybe there's a mix of these points. What if I can use some color marks to show what points are there which belong to different classes? So I can use a package called as cbon. So in here I have imported cbon and the matplotlib. So I just want to add legends. Okay, so if I run this cell, you can see this. Now these points got colored. Okay, so if you see these blue points, they are setosa, iris setosa flowers. So you said that they are clearly separable. This is called as linearly separable. So what is the meaning of linearly separable? I'll just write it down. So there is something called as linearly separable. Linearly separable. So you saw that in our plot we had points like this was our plot, and we had points like this, and then some other points like this, and then we had points which were a mix of these things. And clearly you saw that the setosa, it was sort of separable from other things. If we draw a plane, if we draw a line in here, you know, from your class maybe 10 or 11, you might have seen that the equation of straight line is y is equal to mx plus c. So if I can draw a linear line, maybe a line is like this, or in the 3D, if I can draw a plane and I can separate the data, I call the data as linearly separable, because by drawing a line or a plane or a hyperplane, we can separate the data. So here you saw that this setosa, it is clearly linearly separable from other two, but on the basis of, I think, petal width, and petal length. So if I only use these two features, and if I can somehow make this line and make this separation, so I can clearly say, if I use this plane, so here on the left side of the plane we have setosa, so on the right sides we have non-setosa, virginica versicolor basically. So that's why the first thing I got to know that I can separate setosa only by using two features, feature petal width and petal length. So that's the first thing I got from the graph that is shown here. So I made this graph by using the cbon. So in here you saw that there is again sns dot scatterplot is the function. In here the x-axis is sepal length, the y-axis sepal width. Then we have this class. Hue means the color based on which we colored these points, and the data frame is iris data frame, and This palette is basically what are the color that I think you are using. So you should look for the documentation if you want to understand all the features. So I hope that by just seeing the sepal length and the sepal width, I am easily able to sort of separate these iris setosa flowers. So I got at least some understanding. So by using the sepal width versus sepal length, I can create a hyperplane or a line which will separate setosa and non-setosa flowers. Is it clear? Amir Sharif is he's putting the thumbs up, and others I'm not seeing. Ah, now I saw it. You can also create what are called 3D scatter plots. So in that, here you saw that there are only two features. The first feature was sepal width and the other feature was sepal length. But in the 3D plots, what you can do is you can give the three features. So you can give sepal width, sepal length, and maybe petal length as well. So you can use the matplotlib libraries, and then you use something called as MPL toolkits. And there are other things like which will work online, and from there you will be able to rotate the things. But I just want you to show a 3D scatter plot. So in here I'm using sepal length, sepal width, and petal length. So you saw that these three features are there. So now I can make a hyperplane. It's not clearly visible here, but I just wanted to show you that we can make a 3D scatter plot. So by 3D I mean this is the sepal length, now we have the sepal width, and then on this axis we have the petal length, and based on that you saw the points on 3D. Okay, and and you can move it as well and make in the plane so that which separates the data. So you can make these 3D scatter plots. So how many of you agree that we can make 4D plots? So do you feel that we can make 4D or ND plots as well? Nice. Rian said no. So how many of you are with Rian? Okay. So because our eye we are only able to visualize till 3D. So that's why we cannot visualize more than that. So that's the beauty of maths. The beauty of maths is mathematically we can make ND things, but maybe our brain is not able to comprehend that visual things. We cannot visually visualize this. We cannot make ND plots in our head, but by using mathematics, linear algebra, and things, we can make these ND things as well. Okay, but here we have 3D scatter plots. We cannot have 4D scatter plots because we won't be able to visualize that. So till 3D scatter plots, you can see how we'll be able to make an hyperplane. So hyperplane like this, we can make a plane, and we can separate the data as well. So in the 2D, we can make a line separating the data points. Then in the 3D, we have a plane. Then in the multi-dimension like ND, we call it a hyperplane. Hyperplane. Okay. So I hope this thing is clear now from the scatter plots. The important thing is what do you observe from it. So whenever you are making a graph, you have to write your observations. The first thing from the observations is you saw that by using the petal width and petal length, we are able to separate setosa and non-setosa. Setosa and non-setosa. And another observation is this is linearly separable. This is linearly separable. These are the observations that we saw. So whenever you are making a graph, make sure you're observing something from it and you write these observations. So if it was like this, for example, these points were something like this, and then you had some other class of points which were like this, something like. So this was not linearly separable. So you could have separated it like this. So now this is not a linear plane. This is a non-linear plane basically. This is not a non. This is not a line. It's a curve now. So this was not linearly separable. So I wanted to make the distinction clear between the linearly separable and the non-linearly separable. So that's why I made this diagram. So from the scatter plots, we got to know by using the features like petal width, petal length, we are able to separate the setosa from non-setosa. That's the first observation we made, and we saw that this separation is linearly separable. It's not non-linear. We can just give a line y is equal to mx plus c, and we'll be able to separate these. On the left hand side we'll have setosa, and on the right hand side of the line it will have non-setosa, virginica and versicolor basically. These are the observations that we saw. Okay. Then we saw 3D scatter plots, just for the sake of completion as well. Then if you want to sort of see the things in this, so here we have compared sepal length comma sepal width. But if you want to because we have now four features: petal length and petal width. If you want to plot all these data points by using all the combination of these things. So maybe sepal length versus petal length, maybe sepal length versus petal width, sepal length versus petal length, not even length, petal sepal width. So if you want to compute and if you want to draw the graphs like this, so for that you have to make separate graphs in there. So if you want to make the comparison between each of the two features, so how many combinations are possible? If you know permutation combination, so we have four features, and out of these we take two at a time. So there will be four C2 combinations. So it will be 4 factorial by 2 factorial by 2 factorial. So it will be 4 into 3 by 2. It will be 6. Not even 6. 4 threes. Yeah, I think 6. And there will be 6 graphs. I hope so. There will be only 6 graphs. Not even 6. I think there should be more. I'm making some computation mistake, but there will be 4 C2 combinations. I don't want to make this computation. So 4 C2 combinations will be there. Just compute it by using the formulation of permutation combinations. So here we'll be making some graphs, and in that what we have is we'll be having some bunch of graphs like this. So for the first we'll have, for example, let's suppose sepal length, and here we'll be having sepal width. Then we'll have, let's suppose, sepal length and petal width, things like this. So we'll make different graphs over here. So we call them a pair plot. We call them pair plots. I think we have also covered the concept of pair plots. The pair plot is basically where we want to make a scatter plot by using all the features and all the combination of the features, and we use two features at a time. So here sepal length versus petal length, sepal length versus petal width, sepal length versus sepal width, and these are the number of combinations for C2. So n means the number of features we have, C2 means because we are taking two features at a time. So these many combinations are possible. So in order to understand the relationship between all the different features. So here you know that matplotlib as well as seaborn, it gives us a pair plot function. We can plot these pair plots as well. Okay, so here I have used the seaborn's pair plot, and if I want to plot them, it will take a little bit time. So how many plots are there? 1 2 3 4 5 6 7 8 9 10 11 12. So it will be 12 plots. So 4C2 basically means 12 plots. Okay, so if you see this plot now, the second plot that we have, this first plot is called histogram. So we'll look at these. The first plot, in the y-axis we have sepal length. Okay, then in the x-axis we have sepal width. So this plot is basically sepal length versus sepal width, this plot. Okay, then sepal length versus petal length is this plot. So from this plot, which plot looks linear, like where you can separate these things out? So can you sort of figure out using which plot we can separate out the thing? So if you see this plot, the second plot, this plot where my arrow is, so you can clearly see again the setosa things, they are sort of separate. So by using the sepal length versus petal length, you can again make the distinction between these the setosa and non-setosa. I think this is also pretty much like separable. Here you saw the randomness. By this you can easily try to see which are the two features. By using those I can sort of separate these different classes by using the pair plots. So you are here you are plotting every feature versus every other feature to see which features are more important. So are there some is there a feature are there a set of features by the help of which I can separate all three classes? I think this is more or less like this graph, petal length versus petal width. So here set iris setosa, because this legend say iris setosa is blue, it is clearly separable. Now we have this iris versicolor, so they are in this portion. If you see in the upper portion, in the iris virginica they are in this middle portion. So they are somewhat separable by using the petal length and petal width. So do you see? Does everybody agree with me that by using this petal length and petal width, we are able to separate these things? Not exactly, but to some extent. Okay. So what we do with the pair plots is we'll plot every feature versus every other feature to see what features are important. So if I see this is the petal length and petal width, so here we should have petal width and petal length, and these graphs should be symmetric. So these graphs will be symmetric. They'll be just rotated. If you see this graph where my arrow is, so this graph basically is petal width and petal length. So if I take this petal width and petal length, where is that? This is the petal width, and then I have petal length. It's here. So this and this graph, if you see this where my arrow is and this graph, these are symmetric. They are just axis. The change, there's the change of axis if you see it. So one was in the initial part we had it on x-axis, then on the other features on the y-axis. These two graphs, the petal length versus the petal width. So here we have petal width in here and petal length here. So this graph where my arrow right now is this graph, and this graph is just the symmetric graphs because they have the same two features. So basically we need not to plot everything here because for 4C2 combination you can divide it by 2. So 4 and C2 divided by 2. These number of graphs you can observe. So is the last part clear what I told you? What I told in the pair plot is necessary that you plot all these graphs. So what we did is we plotted 4C2 graphs in here. But you know that half of these graphs were symmetric. Half of the graphs were symmetric. So what we can do is we can plot NC2 divided by 2, these many graphs. So because you know that there is a symmetricity in the graphs, so it is best to just plot the half of the graphs to get an idea. Is it clear? So what is the observation? So I told you, plotting every graph we must write observation. Now I want to see what are the observations that you saw. What is the observations that you saw? I think, whom should I call? Rian, are you there?
Yes, sir.
So what are the observations that you saw in this pair plots? So here are the pair plots that we have. They are separable, but by using what features? By using this petal width and petal length. So this is the first observation that we saw, that all the classes can be separable if we plot this petal width and petal length on the graph. So this is the observation that we saw by using the pair plots. So what is the other observation that we learned about pair plots is that we can just plot half of these graphs because they are symmetric graphs. It's not the observation regarding the data set, but it's a general observation that I told you. Should I move ahead with the other graphs? Okay. Now what we'll do is we'll do something called as univariate analysis. Okay. So first let me tell you the limitations, because there are limitations of these graphs as well. So limitations of pair plots. The limitations of pair plots. Now you know that by using the pair plots, it's really easy to sort of see the relation between these features. But the problem with them is, as the features increase, the complexity also increases. So as you saw that with 4C2 we had 9 graphs. So with NC2 you will have the complexity will go to n factorial. Okay, nearly n factorial complexity. So it won't be like feasible to analyze these many pair plots. So pair plots are used if the number of features is less than, let's suppose, I'll say 8, not even more than 8. If it is like more than 10, it really becomes hard. So less than 8, even 4 or 5 features, okay, then you can plot these pair plots. So that's the limitation of pair plots. So the problem here is that it really becomes difficult when the number of features becomes more. Okay. So you cannot use the pair plots always. So you have to do some other analysis in order to understand the data more. So now we'll do what's called as univariate analysis. So univariate analysis. Okay, maybe we'll just read the theory about univariate analysis. Then we'll, in the next session, we'll again write the code related to our data set to understand it better. So what is univariate analysis? It focuses basically on the individual variable. It focuses on the individual, whatever the spelling is, individual features or maybe individual variables. That's why it's called univariate. Uni basically means one. So at a time it will focus on one feature. Okay, let's suppose for the iris data set, if we want to make this univariate analysis, so you can analyze one feature at a time, or maybe you can analyze sepal length, sepal width, petal length, or petal width. So what are some ways by which I can perform this univariate analysis? The first thing that I can do is by using the histograms. In order to make the clear why histogram is used, let me first draw a 1D scatter plot of by using the sepal length so that it becomes clear. So why do we need histograms? So here if I'll use this seaborn to create 1D scatter plot of sepal length. So you can clearly see that this 4.5 to 8.0 is the value range of the values of the sepal length, and this is the distribution of the points. But you saw that some points in here are on top of each other. So here we are not able to see how many points are there which has value 5.0, or how many points are there which have value 5.5, because they are jumbled here and there. So for that, we'll create an histogram. So what histogram is? It basically is a graphical representation. So histograms, the graphical represent that display the distribution. So it's a graphical representation that show us that describe the distribution. Describe the distribution of data. So why is it important? Now I told you that this comes under univariate analysis. So if you want to see what is the number of flowers that are setosa and which have, let's suppose, the value of sepal length is 4.5. So you want to see how many flowers are having the sepal length of 4.5, how many flowers are having the sepal length of 5.5. You want to see the number of flowers, maybe count the flowers, and you want to see it in the visual format. So for that, you can use the histogram. The first thing histogram has, the components are number of bins. Number of bins basically means the intervals or the range that data is divided into, because now you know that the data that we have, it is ranging from 4.5 to 8.0. Okay, this is the range of the data, and you know this range can be continuous, but you have to make a bin out of it. You have to make bins. So I'll say, for example, let's have 5 bins. 5 bins means I'll have 4.5 separated with 5 values till 8.0. So I'll just have 8 bins, and they'll be equally separated. Okay, so bins means we'll have this range of values, and we'll discretize it into some discrete values separated by the equal distance. So it will be intervals of values, intervals. So this is the number of bins. So we can compute this number of bins. Okay, so we have this number of bins. Then what is the other thing that we have in the histogram is called a frequency. So we have number of bins. So that I told you, there are like what's the intervals that you have in that range of data. Then the second thing that we have, that's called the frequency or the counts. Now you have these bins. For example, you have one bin of 4.5. You have other bin of 5.5. Maybe you have other bin, let's suppose 6.5, and you have 7.5, and at the end you have 8. So let's suppose we have these 4 bins. So in each of the bin we'll have some values. Whatever falls in this value 4.5 will have the frequency of that. Let's suppose we have 5 points in here. The frequency is how many points are there in each bin, is the frequency of that. Okay, so these two things are important: the number of bins in histogram and the frequency that point falls in that bin. Okay, so what is the why do we read about this histogram? What are the key aspects of the histogram? It tells the shape of data. It gives the shape of data. So how data looks like, it gives us shape of this data. Okay, the other thing is it tells us the central tendency. Central tendency central tendency. So how does the data behave, like what it tends to, the central tendency or the mean we call it, or the for in the if you have heard about Gaussian distribution, you saw that the mean lies there. For example, in the mean value there are most values lie on the mean. So that is something, there is a bell curve like this. We'll learn about all these distributions, but I want you to know, by the help of histograms we'll see what the central tendency of the data. Okay, it also tells you about the dispersion. What is the meaning of dispersion? The spread, basically how much spread is there in the data, because as you saw that we have values ranging from 4.5, 8.5, 8.0. Let's suppose if in the 4.5 value we have only, let's suppose, one value. So the value 4.5 value, we can leave that, because the frequency of the other values may be more. So we can say that this spread of the data is from here to here. So it gives us the spread of the data, so how much data is dispersed. It gives the central tendency and the shape of data. What is the shape? Is the data like this? Is the data like this? Okay, so this is the shape of data. It can be like this, it can be like this, or it can be some other shape. And central tendency means what is the mean. Let's suppose this is the central tendency of the data, and then it shows the spread. So spread in here is like this. This is the spread over in this graph. Okay, so let's make an histogram in the code so that you understand it. Okay, so here we have this. What do we have? We have this plt dot figure. Then the figure size is 8,6. So now it's a univariate analysis. We'll just use one variable. The one variable we'll be using is sepal length in here. Then we are saying bins is equal 20. So as you know that we have 4.5 to 8.0 values, so number of bins will be 20, and we are giving a color sky blue, and the edge colors are black, and then we're giving the title as well. So we are actually basically seeing the frequency. Let's suppose we'll start with 5 bins. Now you can see this. Like in the range of 4.5 to this 5.0, you have these number of these number of flowers in there having sepal length of 4.5. Then this 5.0 to 5.5, we have these number of, there are 40 flowers having this. Okay, so it gives a shape of data. You saw this, and if you increase the number of bins, let's suppose we increase the number of bins to 40, it will give us a good shape of data. So what's the shape of data? Why is it not writing? Okay, I think that is the problem. Okay, okay, so if it allows me to write 40 bins, there is some problem with this. Okay, it worked. Now you see this is the shape of the data. You saw that in this value there is no flower, so you saw there is a certain shape. But if you change the number of bins, let's suppose to 20, and you saw a clear shape, you saw that the central tendency is somewhere around 5.0 to 6.5. So this is the central tendency of the data. And 8.0, there are very less points that are around this corner and around this corner. So this more or less gives the shape of data. So this is the shape of the data, and then we have the dispersion as well. So this is how the data is sort of organized in here. Okay, so how to interpret this thing? The first thing is, should see the peak or the center. The highest bar shows what's the peak value. So here 16 is the peak value. I think it occurs at 5.0, and let's suppose 6.3 or something. So 16 flowers have this value of 5, and 16 flowers has this value of nearly 6.3. That's the peak value or the center value. So spread is the width that we have. The width is here. So this gives the spread. And there is a concept called skewness. Skewness is something, data can be left skewed, right skewed, or maybe it can be symmetrical. So what I mean by skewness, I'll just show it. What's the meaning of skewness? I mean, so I'm just telling you how to interpret this histogram now, because we are interpreting the data that we have. So if your data looks like this, so you saw that it is symmetrical. If your data is somewhat like this, for example, it is like this, so it is right skewed data. This is right skewed. If you have data like this is left skewed. This is symmetrical. So by using the histograms, you can know that is there a right skew in the data, is there a left skew in the data, or is our data symmetrical. I think the time is over. So we'll be again starting with our univariate analysis in the next session. I hope that you learned some things about this session, and I'll just stop the recording.